printing is the process of creating a 3D object from a digital file. It may also be referred to as additive manufacturing because thin layers of the object are added together, slice by slice. If you've ever seen a 3D printed object, you can see these distinct layers. Each layer is essentially a cross-section of the object for a certain height. The end result is virtually any object created layer by layer, and people have 3D printed practically everything. From tiny toys and keychain doodads all the way to concrete houses and organs, the possibilities are practically endless. 3D printing begins by creating a 3D digital model of the object to be printed, and this can be done in a couple of ways. Typically, the object is created in computer-aided design or CAD software. The most advanced forms of these programs can cost thousands of dollars for a license, but there's also free open source software available, so anyone can 3D print. The other option to create a 3D model of an object is to use sensors to scan the desired object, and then use software to compile this data into a single 3D model of the object. For example, someone could do a 3D scan of their head and then turn it into a 3D model and print it. There are even free apps that can do this 3D scanning for you. After the file has been created, it then has to be prepared to be printed. The main step here is called slicing, that is, dividing the model into hundreds or thousands of layers, which are then printed one layer at a time. The number of layers to be printed can be varied in order to create a more detailed part with smoother edges, at the cost of a longer print time. The actual printing process will vary based on the type of material and printer being used. In general, though, a length of plastic cord called the filament is fed into the printer, where it is heated up and then extruded out of the tip and onto the printing bed. The tip then moves around, drawing the first layer of the object. When the first layer is complete, either the print bed moves down or the tip moves up, and the next layer can begin. This process is then repeated for each layer until the object is complete.
3D printing can be used by practically anyone for a large number of uses. For example, one of Penn State's Lion Tech rocket labs used a 3D printer to create fins for their rocket this year. One of its main uses is for rapid prototyping. Before 3D printing, injection molding was the most common way to create plastic parts. It's still the quickest way to mass produce the same part over and over, but creating the first component in injection molding takes a lot of time because the mold itself must be created. With 3D printing, an initial prototype can rapidly be created by simply making a 3D file and printing it out, rather than going through the entire injection molding process. This is extremely useful for creating numerous prototypes and testing them. Creating individual parts might take a while for 3D printing, but is far easier, faster, and less wasteful than creating molds for injection molding. 3D printing also has incredible use and potential in the medical industry. 3D printing custom components for prosthetics and implants allow for far superior quality. Besides prosthetics, 3D printers are also being used to create entire organs by printing them out cell by cell or creating a cell out of biomaterials that the body's own cells can grow on top of. This technology is being used to solve the current organ shortage as we live longer and longer lives with more organ failures, with the same number of organs donated. In the past, pretty much all machining besides injection molding was done through subtractive manufacturing processes. That is, you start with a piece of material and use various machines like lathes and routers to remove material until the final product is all that remains. In the words of Michelangelo, every block of stone has a statue inside it, and it is the task of the sculptor to discover it. 3D printing changes this, and it is now possible to start with nothing and create a new object. 3D printing technologies first started to be patented in the late 1980s and continued to grow as a rapid prototyping technology during the 1990s. In the early 2000s, the technology splintered into two main variations. The first was the continuation of extremely precise, high-end printing that is used today for machining extremely accurate parts. For example, the FAA recently approved the first 3D printed part to be used in General Electric's jet engines, and in the automotive industry, parts are commonly used to test in new vehicles. Note that these printers have the capability to create metal parts, not just the simple plastic components that are commonly used in commercial printing. Speaking of cheap, commercial printing is the other major variation of printer technology that broke off in the early 2000s. The goal was to develop a cheap printer that any layman can use for developing proof of concept products, and to make this printer available to a wide audience. In this aspect, 3D printing companies have succeeded. Nowadays, anyone can buy a 3D printer on Amazon for about $250 and even have it delivered with Prime in 2 business days. There are even 3D printing pens that one could buy for about $70, which extrude a thin line of melted plastic, doing essentially the same thing as a 3D printer.
Some predict that 3D printing is going to completely change the way commerce works. Instead of buying something online and having it shipped to your house, people could just purchase the 3D file for products and then have it printed on the household 3D printer within a couple of hours. In fact, there are already websites such as Thingiverse.com that are already being used by the public to create and share 3D designs. Even if the future does not hold such a 3D printing-centered economy, it is undoubtedly set to change the way products and prototypes are manufactured. 3D printing has already become popular in many diverse industries. Companies, like Nike, are already using 3D printing to quickly develop custom prototypes of new shoes. Also, in the medical industry, 3D printing will hopefully continue to develop to the point where entire complex organs can be easily printed. This is an especially important issue since there is a shortage of organ donations, leading some people to wait years and in some cases die before they receive life-saving organs. Controversies involving 3D printing. There are a couple of controversial issues that come with 3D printing, as expected with any technology that is upsetting major industries and upsetting the legislation that goes along with those industries. One such example is the idea of printing a patented object. If someone uploads a 3D model of a patented toy, for example, is it wrong to simply download the file and print it yourself? One other controversy is the possibility of downloading files for illegal or controlled items, such as firearms. While printers required to build firearms are certainly out of the price range of most individuals, some with the right motivation and funding could possibly purchase a metal printer and use it to create firearms without serial numbers and sell these firearms on the black market. These are all issues that have to be solved as 3D printers become more and more prevalent, and new legislation will have to be created that regulates this up-and-coming industry. Although the benefits of 3D printing without a doubt outweigh any possible controversy, 3D printing will allow for far quicker and less wasteful manufacturing and even create brand new organs that could save countless lives.